Hello everyone, welcome to my next tutorial. In this tutorial we will be discussing about the 4-terminal tandem solar cells. Before we start of the session, I want to introduce myself. I am Sahil Verma, working as application engineer at the well-known company Impulse Technology. You have seen my previous video related to the Setfos software. Who has not seen it, please check out the playlist. Number of the video available related to the Setfos softwares, how you can work on this software. Newly updated version of the Setfos 6 have already come, so now we will be simulate 4 terminals tandem solar cell in the Setfos 6 version. Like thermal modules have added in this Setfos new updated version. About the 4 terminal tandem cells, you can see it means two solar cells subcell stacked optically, but they work operating electrical separate. Generally, it means when you create the two terminals, it is like a series. But when you work on the four terminal, it have divided in the two parts. One is the top cells, second one is the bottom cells. And then top cells absorb high energy photons and some of the unabsorbed lower energy photon pass through to the bottom cells. Both cells generate power independently, and then total power is sum of both. Generally in the two terminal you can see the electrical connections. The subcells connected in series as we have already told, and subcell independent. Terminal in here the 2 and in the 4. Current, same current through the both but independent current. In here 4 terminal it does not need to the current matching, but in the 2 terminal it need VOC, open circuit voltage. Some of the both subcells and independent had not added. Optimization needs current matching and easier independence. In here you can see the 4 terminal tandems optically filter subcells. You can create first top cells, then bottom cells. After the top cells simulations, you can take the transmission spectrum files as that spectrum for the bottom cells that known as the filter subcells, and then you can simulate. Generally, electrical simulation is independent according to the top cells. I will show in the Setfos software how you can work on this. It is just some of the screenshot that we have attached in here, and it is a 4 terminal tandem subcells results. You can see electrical key figures for the top filters and their results, and for the bottoms. In the Setfos give the ability to you can compare your results as well as in the Setfos software. It is for the two terminal efficiency and it for the bottom and tops. Then you can add and then it will make for the 4 terminal efficiency. In the 2 terminal you can see due to the series connection. In the 4 terminal you can see it is individual operations. So now I'm going to open the 4 terminals. Who want to simulate the 4 terminal tandems? So you will be simulating the Setfos software. You can't directly simulate 4 terminals. You need to create 2 separate cells. So now I'm going to open the Setfos software. I will show how you can simulate your properties. Click on the right side and run as an administrator. You can see feature highlight in the Setfos 6.0. It is the newly GUI look. You can see some of the geographical user interface have changes in here. Number of the things are same, but some of the look wise and one of the thermal modules you can see in here we have added. Band to band tunneling, intra band tunneling, some of the mobility features, number of the things we have added in here. So you can see the feature on the Setfos newly versions. When you started work on this Setfos software, so you get to know how much they have upgraded in the previous version. You can compare on this. But at the soft descriptions I want to give in here, like if you want to create your new simulations file, click on this. Number of the existing examples present on this, so you can check on this. If you want to save your projects, you can use this tabs. It is a workspace view and it is the stack view. You can see like this. If you want only this, you can click on this. If you want refractive index, so it directly connected to the material database where refractive index files are available, so you can directly add. Number of the refractive index files is given. Firstly, it given on the Setfos have the own refractive index library, but in here we have added through the material database, so you can directly add from here if they are available. So you can click on this tab. It is a passive optics, reflectance, transmittance, absorption parameter you can calculate, and it is a absorption module. Emission modules where you can calculate emission properties. Scattering modules, you can calculate scattering parameters. And electrical modules, it is a thermal modules. Master equation modes, Shift modes where you can vary a different properties. It is a same optimization mode where you can extract your parameters, and it is a fit emission zone. So you can see some of the look wise they have changed it in the previous one. So who are work on the previous Setfos software, so you can see. And it is example portions, and it is the same here. You can provide the inputs and script modes, console view, layer stacks, and result. Now I'm going to create in here the 4 terminal tandem solar cells. First I will create the layer stacks one by one. We will be add each of the layer name and thickness as well as interface. So you can add unlimited layer here. Then you will be provide one by one each layer names. It is the surrounding, it will be same 0, and refractive index properties like refractive constant, it will be 1. In here you need to give glass thickness, it will be 1. Unit you can see nanometers, micrometers, millimeters, and water wavelength. So you need to give in here the mm, and you can see the reflective data properties. After this you need to give in here the another layer name ITO. It is one of the conducting oxides. Thickness it will be same 100, and one of the self assemble monolayer you need to give. I'm just taking one of the examples parameters. So you can choose one by one according to your layer stacks, which type of structure you want to create. First I will provide in here the one by one layer name and thickness. Now you need to add in here the one of the interface layers. So you can give it the interface parameter we will be add after the layer stacks, and then we will be add one of the perovskite top absorber, give here the thickness. After the perovskite, you need to add one of the more interface layers. So you can add carbon nanotubes, one C60 tops you can add. Thickness you need to add in here the 20 SNOX. Thickness you can give in here the 45 nm. Again you need to add one of the interface layer in here, P PSS, and 50 nm thickness. Again you need to add one of the interface layer. Then bottom perovskite absorber layer you need to add in here. So you can add one of the perovskite. Again you need to add in one of the interface layer and one of the ETL layer for the bottom absorber, C60 bottom. You can add again one of the layer and give in here the name BCP, one of the electron buffer layer. Thickness you can give in here the 8, as well as C60 thickness you can give in here the 20, and for the perovskite you need to give in here the 600. So you can give like this thickness value AG, and it will be the same 100, and give in here the one air bottoms as well as you can give and 100 mm thickness. So you can see it is a layer name, thickness, and interface we have added. Generally interface it will be help to reduce the trap between the ITO and perovskites where we have added. So we have added in the interface. It is a theory parts. You have the a lot of the knowledge related to this. Why we are added interface. Now one by one we will be provide the refractive index properties, and we need to import in here the wavelength dependent files like wavelength and k refractive index files. Which layer it is a wavelength dependent, so you need to import one by one. In here the glass you need to import glass 40, like this you can add. Same one by one you need to import in here. And newly version we have added in the Setfos 6 refractive index material database file already available. So that file are not available in the Setfos library. You can add from here. You can see it will help definitely to you. In the self-assembled monolayer, you can add n equal to the 2 and refractive constant and extension constant you can add any other. That means imaginary parts it is 0 in here. You can import as well as same one by one each of the files. For here you can give 1. In a previous video we have already discussed if the refractive index files are not available, so you can directly edit from here and you can give in here your own data. And generally in the new version Setfos added some of the material database, so you can also collect from it. You can see in here the general tab, so you can also enable for that self assembled monolayer with the transparency, and you can select in here the discretization element. That discretizations means you can reduce your calculations as this element's number, because Setfos calculate each and calculations. So layer stacks are completed in here. Now you can activate the absorptions modules. In here you can see SIP or single wavelength or wavelengths. So you can select in here the ranges 300 to 1100. Step it will be same. If you want to change in here the spectrum files, you can change. Like you can see number of the spectrum files are available in here. Intensity scaling, amount of the diffuse lights, and default parameters are given. The newly tab are added ideal transport JV, so it will also activate as when you give the electrical parameters, and total device series resistance value you can also give in here for the ideal transport. About the absorptions modules we have already discussed, like white spectrums, location and date and time, so that already available in the Setfos software. Now you need to activate electrical modules to give the electrical parameter for the top cells like this. First you need to select one of the top cells, like ITO we have selected, and so you need to enable in here the electrode as ITO and give in here the value 5.1. Injection model you can see thermionic organic, thermionic inorganic, and work functions. It is a boundary condition that we have given. In between the electrode you need to define the semiconducting layer, so enable this semiconducting step, and now you need to import one by one electrical material files. You can see you need to import these files. The new features that we added in here, you can see density of step types, and here the parabolic and Gaussian things are given. Another things, it is the same: homo, Plomo level, effective density, dielectric constant, acceptor doping, donor doping, layer polarity, and some of the mobility features you can see constant diffusion constant, temperature dependent diffusion constant. So some of the things that already given in here. And if the files are not available, so one by one you can also provide each of the value. It totally depend on the users. You can also edit from here directly if they are available. Same for the perovskite top observer, you need to import. First you need to enable this files and you can directly click and then you can import. Same for the C60 tops, give in here and you can import. By mistake I think they have active. You need to select as a SNS semiconducting layers, and then you need to import the semiconducting files as well as, and after this you need to select P.PSS as a electrode. It is a bottom electrode and it is same. You need to give in here the work functions value 4.25. Now you can provide one by one each of the interface value, and you can see the electrical interface will be enabled in here when you enable the electrical modules, exciton dissociation, hopping, and interface traps and interface recombination. You need to enable the interface recombinations and give in here the electron recombination velocity. It will be 0.2. It totally depends on the users. I'm just selecting examples value, and for the interface you need to enable recombination. For this interface, give in here the 10 10 and trap energy offset, it will be 0. For this interface you need to enable hopping interface and click on the advanced. You can see attempt frequency or advanced, limo limo, limo homo, homo limo, homo homo. So now you need to give in here one by one each of the value. CLs minus 20 and 1 for the limo homo. It is a attempt frequency, and 1 exponential minus 20, 1 exponential minus 20, and click on the electrical field barrier lowering. So you can provide this type of interface value. When you move with this interface, you provide again electron recombinations velocity, it will be 1, hole recombination velocity 1, and trap energy offset will be 0. For this interface, again enable the recombination for this interface and give in here the 7, 8 and 0. So you can provide this type of interface value. After this, you need to enable electrothermal settings. You can see different modes are available: transient AC, intensity modulated photocurrent spectroscopy and voltage spectroscopy. In the steady state, you can see electrical source voltage for the series and current. If the DC voltage will be used for the operating of the device, you need to select in here 1.8. It is the temperature where the device at this temperature it will be operated. Disables language recombinations, trapping, doping, mobile ions. You can see some of the band-to-band tunneling, intra-band tunneling features are added in here. Enforce global density of states. That's some of the extra features also available in here. You need to enable electrical circuit settings. You can give in here the device area unit. You can see, but we have selected square, and parallel resistance you can give in here 200, and different units are given, but you need to select clone it for the external loads when you want to connect it, so you can use this. And this will be enabled when you want to calculate this type of property, because we have given in the layer stacks. If you move with this like excitant, traps, mobile ions, recombination, you have given any type of electrical inputs in here, you need to enable this. After this, you can enable shift setting parameters, and when you move this, you need to select or enable this, and you can select the voltage. In here you can see different type of properties are given, and you can variate your properties according to this. Number of the things are given. We have selected in here the voltage ranges, you can see, and select 0 to 1.3, 0.01. So absorption setting, electrical properties settings and shift settings have completed in here. You can see at the 4 terminal tandem, so you can give here the new names and you can simulate your parameters. Before this, you can see the script mode. If you want to change any parameter related to this, you can change. It totally depend on the users. If they want to change related to this settings, it is editable. Click on this play button. You can see 4 terminal tandem top cell results, play key figures, open circuit voltage. Result may be the different, because when you choose the input, result will be totally depend on your input parameter. Built-in voltage for the large wave, you can see like this. Current of circuit, current balance, device currents. In here you can see device recombinations, molecular trapping. So you can check one by one like this. Y-axis, x-axis ranges also given in here. Electrical power, interface, SRH current, power conversion efficiency. In the electrical profiles, you can check charge density, band diagram, charge density, charge generations, currents, electrical field, mobility, potential, recombinations, trap capture rate. It is a numerics for the iterations, the residual errors. Optical integrated, when you vary the thickness according to the result will become. Absorption profiles, passive optic properties, you can check one by one. Absorptions, it totally depend on this steps. If you increases the steps, it result will be changed according to this layer absorptions. Like you can see, this is the result portions. ITO glass, reflectance, state contribution and transmittance. If you click on the right side, you can see image, data, Python. So you can export your results, you can compare your results. If you want filter subcells, so you need to select this transmission spectrum, save visible data, give here the name, transmittance spectrum 40, and you can save. For the optical filter subcells, when you move with the bottom subcell, you need to this spectrum files. But if you want to the move with the default top and bottom cells, so you not need to import these files in here. Now we are going to create in here the bottom subcells for the 4 terminal. You need to select SNOS as a electrode and AG one of the another electrode like this. And you need to disable for this semiconducting layers, as well as this semiconducting layers, as well as this semiconducting layers. And at the same procedure, in between the electrode, you need to enable this semiconducting layer for the pedot. And in the semiconducting, you need to import p.pas electrical material files. You can see p.pss 4 terminal .em files. Same for this. You need to enable this perovskite semiconducting and need to select this electrical material files. Same for the C60. You need to enable, go with this and need to import this file. Same for the BCP. Now you can see pedot, NBG Pero and C60 and BCP semiconducting file have been imported. You not need to change their interface value, they have automatically selected in the top cells. When you move with this shift setting tabs, you need to change in here that value for that ranges because it is for the convergence criteria. If that value not come in this range, so it will be show the error. So you need to change this value 0, 0.8 and 0.001. It will be same. And in here you can give in here that name for the bottom. It is a default spectrum files we have selected in here like this. Like in here you can see we not choose any spectrum. It is that spectrum AM 1.5. You can click on this play button and after this result will become. It is a 4 terminal tandem bottom results. You can see one by one built-in voltage, circuit currents, current balance, electrical profile results, numerics, optical integrated, passive optics results, and it is the absorptions results. If you want to compare this bottom result with the tops, you will be moved with this the control button. Now you can see it is a top, it is a bottom results, and you can add with this maximum conversion efficiency of the tops and maximum conversion efficiency of the bottom, and then it will be result of the four terminals conversion efficiency. So like this you can simulate four terminal tandem solar cells. If you want to calculate filter spectrums results, so you need to import in here the spectrum files of the from the top cell result. In the filter subcells you can directly import your spectrum files. You can see all files and where your spectrum files have been saved, you can directly save from here and then you can simulate your projects. If you want to compare the device current graph with this top cell data, you move with this and click on this top four terminal cells and then you can compare like this. And who want to calculate that external quantum efficiency on this four terminals tandems, so you will be moved with this shift, select at the single wavelength, move with the shift settings and add one of the more tab. You need to disable this voltage and select near the wavelength and click on the 300 to 1200 given here the step 10 external quantum efficiency and click on the play button. At the meantime, in the intensity, you can edit this intensity when you imported the filter subcells, plot, wavelengths, and ranges, and different things you can edit from here. And like this, you can calculate various type of properties like external quantum efficiency, energy yield calculation, or different property you can calculate for provided different ranges value and then you can simulate your properties. Now I'm going to end in here my tutorials related to the four terminal tandem solar cells. I hope you got my tutorials and understand what we are exactly want to tell. You can simulate four terminal like this. You not need to follow that each of the input data. You can choose your own user data that you want to select and you can simulate. It is just a way how you can simulate four terminal tandem solar cells. And who has not seen it my previous video, please check out the playlist and please like, share and subscribe my channel. And if you have any query related to this, please ask in the comment box as well as my email given in the end of the video. Thank you very much.